let's go through LeetCode 2111 minimum operations to make an array k increasing. For this question, they give us an integer array and a k, and let us to find the minimal operations to make the array k increasing. Since that the definition of k increasing is that for this kind of array, for example, 0 and k, 2k, 3k, right? And for this number, they will be non-decreasing. Yes, non-decreasing. And for 1, k minus 1, k plus 1, right? 2k plus 1, they will be non-decreasing as well. So in one operation, you can choose an index I to change this array I to any positive number. So this is that our thinking is that for this array, it is divided to k k subsequences, right? And for each subsequences, we can find the longest non-decreasing length. So it is, for example, in the index 1, those kind of sequence, if we have length L1, right? And the first one have, for example, L0 and L1, the longest subsequences. And until k minus 1, that will be Lk minus 1, right? So the total operations that if for every part we find the longest non-decreasing subsequence, we can change those kind of number which does not fall in does not form the LIS1 to be the same as the number which is closest to its LIS, right? So in this case, we can, because this number can be changed, we are trying to find the minimum operations, right? Because, and also this number can be changed to any number. So we keep the longest LIS1, those kind of index, we don't change them. And for those which does not form this LIS, we can change it. We just change those numbers. So for the first sequence, we are, for example, this length is length minus this, right? And the second sequence is length 1, length 2, right? Normally, this length 1 and length 2 may not be the same, right? Because when we mod by k, that it may be one more than the previous one, right? Then LS2, right? Just so we sum them up, and this one is the total length of array, and we just sum up every longest non-decreasing subarray's length, and so n minus summation of LRS, that will be our result. So let's begin to write code for this. So we know um, there are k set of data, right? So we want is that we want to we'll have k set in I equals 0, I smaller than k, I plus plus, right? And for each set, So for each set, we'll have an LIS, right? At the beginning, it will be 0. And what we are going to do is that for int j equals I, and j smaller than and j plus equal to k, right? And for each part, of course, we need to have a list of integer list, because new array list. Yeah. So for each number, we are going to have int index equal to binary search base list array. Okay. And we'll have used if the sentence if this index equals -1, right? We just append, we have list area array j. Else we just set. Else we're going to have list set index array j. Right. So so we'll have list LIS, right? Equals list dot size. And so in the end, we'll have int n equals array dot length. And we just have n minus equal to LIS in the return. So our result. So now what we're looking is not longest strictly increasing, but it is longest non-decreasing, right? Because AI could equal to AI minus 1, right? So when we put this kind of things in our list, we are trying to find the first element, which is greater than this now. Among the LIS, the strictly that is greater equal, right? Because we see that in that case, for example, that is 3, and we find the first greater. For example, there is 4 here, right? So we are not to replace 3, we will replace 4 instead. So these 3 we are put in our LIS, right? So next time we find the first greater. For example, there is 5. So all of these 3 will be put in this list. So what with binary search is a bit different. Yes. Binary search. Find the first index in list greater than none. Okay. So this is private linked binary search. List integer list int none. Okay. So the same is that if this list is empty, we will return -1, and int start equals 0 and equals list dot size -1. Okay. And while this start plus 1 smaller than n, are going to have in mid the start plus n minus start divided by 2. So we'll say if this list get mean, if this one equal to none, right? Then we'll have we will search on the right part. We'll have start equal to mean, right? So if smaller equal to, right, this is start equal to mean. Then we can have least greater than n to mean, else start equals to mean, right? So we want to find the first, then we compare start first. If let's take a start greater than none, we can start. And if then we try to see if end, right? So end, return end. Otherwise, that means we didn't find any, then return -1. Okay? J smaller than result. This one. Because this result is changing, right? So we can do not use result, which will still use direct evidence. Anything else? Return result. Okay, so the time complexity, right? That is binary search. But we still just iterate the array once, and there is for every element there is binary search. And so that is in log n, and space there is we use list, right? This linear, so that is log n.